Hello, my dear students. I will start with course name Mechanics of Solids. Already I have told what are the course objectives and course outcomes, right? Just will revise in a few minutes. Okay, the main objectives of this course are: understand the principles of material behavior, apply the elasticity principles to beams, columns, springs and cylinders, analyze the state of material under various stresses and strains, design common elements such as columns, beams and cylinders using elastic principles. Okay, these are the main course objectives, and course outcomes are: learn fundamental concepts of stress, strain and deformation, apply elasticity principles to beams, columns, springs and cylinders, analyze and assess the ability of materials to resist failure, then design simple elements such as columns, beams and cylinders, right? These are the main objectives and course outcomes of this course, and I have already told there are 4 units, right? The first unit is with the simple stresses and strains, then compound stresses and strains, and under unit 2 we are going to study about bending moment and shear force diagrams, flexural stresses and shear stresses. Okay, then under unit 3 there are stresses, strain energy and slope deflection. Okay, that unit 4 you are studying about thin and thick cylinders, springs and structural stability. Okay, this is the scheme of the subject. So total 3 hours lecture and 1 hour tutorial. Okay, practical also there, but it comes under the different heading Mechanics of Solids Lab. 2 hours practical. Okay, here the course objectives of this practical subject is need to test steel that is used as reinforcement in concrete, properties that are determined in the laboratory test, various tests that are conducted on steel, interpretation of the test results. Okay, these are the main objectives, and course outcomes are: learn the various testing procedures for different building materials, understand which parameters are to be tested, interpret the results of the test and classify the material based on test results. Okay, these are the main objectives and outcomes of this course. So there are many experiments are there. Mainly at least 8 experiments you have to do. So there are 14 experiments are there in the syllabus: tension test, bending test, compression test on concrete, impact test, shear test, investigation of Hooke's law, determination of torsion and deflection, measurement of forces on supports in statically determinate beam, determination of shear forces in beams, determination of bending moments in beams, measurement of deflections in statically determinate beam, measurement of strain in a bar, bend test, and yield or tensile strength of a steel bar. Okay, after this we will conduct around 8 to 10 experiments, okay, online. So I have told this mechanics of solids. It's also called as strength of materials or mechanics of materials, right? And also this mechanics of solids is also called as mechanics of deformable solids. Okay, this mechanics of solids, it is the main objective of this is the study of internal effects, means stresses and strain. I will tell you what is stress and strain in the next class. Caused by external loads, that is forces and moments acting on a deformable body or a structure, is known as strength of material or mechanics of solids, are also called as mechanics of materials. Okay, so the main objective of this is to determine the strength. It can be determined by stress at failure, then deformation, that is determined by strain, then stiffness, that is ability to resist deformation, load needed to cause a specific deformation determined by stress-strain relationship. Then stability, that is ability to avoid rapidly growing deformations caused by an initial disturbance. For example, buckling. These are the main objectives of this mechanics of solids. Okay, so mechanics of solids means it is also called as mechanics of deformable solids. So first we will see what is this deformable. See, mainly there are two types of body or structures. That is, first one is rigid structure or rigid body, and second one is deformable solids or deformable body. So what is this rigid body? It's also called as a solid body. Okay. A rigid body consists of innumerable particles. Okay, if the distance between any two or its particles remain constant, it is known as solid body or rigid body. The mechanics of rigid bodies is primarily concerned with the static and dynamic behavior under external forces of engineering components and systems, which are treated as infinitely strong and undeformable. Okay, this is about rigid body. Next we will see what is deformable solids or deformable body. A body which undergoes deformation due to the application of external forces, means when you apply the load, it undergoes deformation. Such type of the structure or body is known as deformable solids or deformable body. Okay, so the mechanics of deformable solids is more concerned with the internal forces and associated changes in the geometry of the components involved. Of particular importance are the properties of the materials used, the strength of which will determine whether the components fail by breaking in service, and the stiffness of which will determine whether the amount of deformation they suffer is acceptable. Okay, therefore the subject of mechanics of materials or strength of material is central to the whole activity of engineering design. Usually the objectives in analysis here will be the determination of stresses, strains and deflections produced by loads. Okay, this is about the deformable solids. Okay, next we will see what is this load. Okay, so load, all of you know, I think you must have studied in your first year, right? The load is defined as a set of external forces acting on a mechanism or engineering structure which arise from service condition in which the components work. Okay, so means it is the set of external forces acting on the system or a structure which arise from service condition in which the components works. Common loads in engineering applications are tension and compression. These are the more common load in engineering application, tension and compression. What is this tension? Tension is the direct pull, for example, force present in lifting hoist. Okay, then compression, that is direct push. It is a push force, for example, force acting on the pillar of a building. Then these are the main two types of loads. In addition to this, there are other types of loads also. We will see later. So here sign convention usually we follow is tensile forces are positive and compressive forces are negative. Okay, so in your here we are mainly dealing with the tension and compression forces. Okay, then in addition to this, there are number of different ways in which load can be applied to a member. So typical loading types are dead load or static load. For example, non-fluctuating forces generally caused by gravity. Okay, then live load, that is load due to dynamic effect, load exerted by the lorry on a bridge, for example. Then impact load or shock load, for for example, that is due to the sudden blows. Okay, you just imagine all of these things. Then the fatigue or fluctuating or alternating loads, that is mainly because of the magnitude and sign of the forces changing with time. And these are the some types of loads, and also there are the other loads also, mainly the point load or distributed load. I think you know about this, right? What is this point load? A point load or concentrated load is one which is considered to act at a point. Okay. In actual practice, the load has to be distributed over a small area, because such small knife edge contacts are generally neither possible nor desirable. So this is point load, means it is acting at a point. Okay, that is about point load. We'll see what is distributed load. Okay, a distributed load is one which is distributed or spread in some manner over the length of the beam. Okay, if the spread is uniform, means that is at the uniform rate, it is said to be uniformly distributed load, and is usually we abbreviated as UDL. If the spread is not at uniform rate, then it is said to be not uniformly distributed load. For example, triangular or trapezoidal distributed load, that fall under this category. I think you must have studied about uniformly varying load, right? Triangular load. So this is about the loads, mainly point load, uniformly distributed load, uniformly varying loads. And